I think it's time for a little soldering project, and it's going to be an LED lamp kit, but not necessarily made the way they intend. Now, you can get these on eBay, and they're available in a wide variety. Most of them have the 38 LED circuit board, and the price and what you get varies dramatically. This one's £1.42, and it comes with no LEDs, you have to supply the LEDs yourself. This one's £1.08 and comes with the LEDs, but no sort of dome over the front. This one's 99p, comes without the LEDs, and it's got the dome over the front. And then they go up to a larger one, which is 60 LEDs, £1.92, and it does have the dome. Now, the best way to find these online is just with the keywords. If you do look for energy-saving, lamps, LED DIY, you know, keywords like that will find these. So the different kits, they come in bags. So this is the kit that just has the front without the dome, and the idea is that once you put the LEDs in, it just presses or glues into the front of this. Glue would be preferable, and it basically acts like a sort of spotlight, I suppose, sort of downlighter type spotlight. The other ones have the plastic dome over the front. This is a small version of 38, and this is the 60 LED version with a much larger dome. And I quite like the fact they're not supplied with LEDs, because it lets you put LEDs of your own choice in and make custom lamps, and it also lets you adjust the component values. What else I'm going to be doing here, I normally use these little side cutters, these little electronic snips. I got a couple of pairs off eBay, and this one's quite interesting, this Xuron Corp made in the USA, and this set, which is YTH cutter, which I've not had out yet. Tis now. And the one from Xuron Corp, which is the blue handled one. I say Xuron Corp. It's a bit odd, it says Maine made, as in M-A-I-N-E, America's Best Precision. These are not made in America. These came from China, and it's obviously a clone. I've never heard of this brand, but it's obviously a clone. And if we look at the listings, I think we can safely say that, now it says £1.36 including shipping for these. You wouldn't get them. If these were made in America, you wouldn't get them, you know, for, they'd probably closer to about £10 probably, or $10 to, you know, it's just not viable to manufacture things for less than that in a place like America and Britain. So I actually got these cost when I originally bought them, it was £1.22, but you know, they've done that thing that the price yo-yos up and down, and I see it's a very common listing, and it is listed at £1.22, which is about, let's see, what would that be in American dollars? That would be about $1.75, probably, less than $2. And this is the price this one has remained the same, it's all consistent. It's roughly £1.50, which is probably about the best part, $2 again. And they're just generic electronic snips. They're designed for light duty, they're not designed for really major heavy, just component leads. And they have a modest capacity, you can go up to fairly thick copper wire, but not suitable at all for steel, or, well, in the sense that you get the steel LED leads. They're suitable for soft steel leads, but not for cutting sort of heavy welding rods or anything like that, or springs, which is what I usually end up doing with them. It's just, you know, what comes to hand, and then you just know that the blade is being destroyed in the process. But I'm going to give these a go and see what they're like. It's just it's worth testing them out. So the way this comes, I've doodled the circuit. It doesn't actually come with a schematic. It comes with a pile of components and the little circuit board, and all the component values are kind of marked on the circuit board, except for one, which is the big resistor, R2. And here's the basic schematic. It's a typical capacitive dropper. It's got the power comes in. It goes through a 470 nanofarad capacitor, which lets through a portion of current in each half. The typical voltage capacitive dropper, should I say. It's got the 470k resistor across it to discharge it. That's so you don't get a wee zing off the pins, because without that little resistor there, if you turned the lamp off or disconnected the lamp at the sort of midpoint of a sine wave, then it would leave a charge on it and you could get a wee zap. And strangely enough, you'd also see the LEDs glow at the same time as you got the zap. So then it goes through a discrete bridge rectifier, which is what these little diodes here for the little 1N4 0070 type diodes. Then it goes to the smoothing capacitor, which in this case is a 4.7 megafarad 400 volt one, with another. Now this resistor across the electrolytic is partly to discharge this capacitor as well. It's less needed for that because you're not going to get the shock from the output pins, I shouldn't think, through that. But I think that's more to act as a sort of resistive load to pull the voltage down so you don't get that ghosting effect you sometimes get where you turn the light off, but because the LEDs are so sensitive to even capacitively coupled leakage between the switch wires of your mains wiring, the LEDs sometimes keep glowing. So I think that's what that resistor's there for. Then comes this seemingly, I'm not sure why they chose such a huge value of resistor, such a low value in series of LEDs. I just don't get this. To me that would have been better down here as a fuse type resistor, but they've used it there. And then unusually, the LEDs are all wired in parallel pairs around the back. It's not very clear in this particular circuit board, but they are just grouped in pairs. And there's, let's see, this was about 38, wasn't it? So there's about 19 circuits of those 19 pairs. And I'm guessing that's strictly to keep the voltage across it down so that the same lamp circuit board can be used in 110 volts as can be used on 230 volts or 240 volts. So I'm not going to build it like this though. I've decided to do it differently. I'm going to utilise the fact that LEDs are wired in pairs and then butcher things slightly. So what I'm going to do is, if that's the mains in, I'm going to use much less circuitry. So going straight across the LEDs, we've got the standard arrangement of the LEDs going down in their pairs, but I'm going to wire them in inverse parallel pairs like this, and I'm going to make them different colours. I'm going to make the ones on that side red, so the reds will light in one half of the waveform, and the other ones are going to be blue and they're going to light in the other half of the waveform. And that's going to make the circuitry very simple because they're going to effectively be fed with AC. So all I'm going to do is I'm going to use the same capacitor, so it's going to be the 470 nanofarad at 400 volt. And I'm keeping the, and it's going straight to the LEDs this time, keeping the discharge resistor. Actually, I'm going to probably just stick a 1 megohm resistor. I kind of prefer 1 megohm. And then to limit the inrush current, I'm going to actually add another resistor in series, but I'm actually going to use two 1K resistors in parallel, standard quarter watt 1K resistors, just because it will increase the dissipation of standard quarter watt resistors. Each one will be dissipating quarter of a watt up to quarter of a watt, but it just spreads the load across them. And I'm going to use two 1K resistors, which will actually give 500 ohms. And that's the circuitry. So in each half waveform, it's so simple, you know, it's using hardly any components. On each half wave, firstly the reds are going to light, and then the other half wave the blues. So it's going to alternate red and blue very quickly at the mains frequency. Now, our mains frequency is 50 Hz, so it's going to be 50 times a second. It will shudder quickly between red and blue, which should be quite psychedelic, I should think. So yes, let's make this. Now, I should have actually, I'm just going to grab a resistor. That's the 1 megohm resistor I'll be using as a discharge resistor. Now, here's a solder. Now, someone was asking recently, why do I just snap a bit of solder off and use it on its own instead of just pulling it off the reel? Well, the answer is I tend to get quite big rolls of solder on a mechanical support reel, so it just makes sense to snap a bit off. It takes the burden of, you know, having to hold the reel or it snagging and pulling. I prefer just to work with the solder directly, a short section, much like a sort of TIG welding rod really, and then just I can use it right up to the end, you know, to the point it's less than half an inch, you know, just 12 millimeters or so before I have to get a new bit. So I just prefer the sort of freedom of that. So let's start by getting rid of all the components we won't be using. I don't need that electrolytic capacitor. I will need that 1 megohm resistor there. I don't need these little wire links. I don't even need the circuit board. I don't need any of the diodes. These can all be used for something else later on. I can use that same little circuit board, I can use it as a little drive for the lamp, and I don't need any of these resistors. No, I don't need any of these resistors at all. So all I'm really using is the capacitor and the components I've added, which are going to be two 100k resistor, two 1k resistors, a 1 megohm resistor for the discharging the capacitor, and the circuit board, and that's fundamentally it. So let's start making this right now. The LEDs I'm choosing to use are going to be the straw hat LEDs. Now it's worth mentioning, because these are in parallel pairs, I have put little red dots already on the circuit board to identify. Most of them, it doesn't really matter which, the ones that they are just pairs all around, and I'm going to be putting an alternate polarity anyway. But in the case of these two, these are a coupled pair that aren't in nice, groups round the side. So I just link those just to make sure I don't, to make sure I do keep it in inverse parallel pairs. So I don't put like two in reverse, but in the same sort of pair, so to speak. It would just damage the LEDs if I did that. Well, that was as clear as mud. So I'm going to start by sticking the LEDs in. The first ones I'm going to put in are the blues, and I'm going to put them in every second LED position, and I'm going to put them in the correct way according to how it's shown on the circuit board. So I'll just start putting them in now. You could, of course, just use any LEDs you wanted for this. You don't even need to use the same colour throughout. If they were all genuinely in series without being in these little pairs, you could have just mixed and matched any colours you wanted, but the fact they are wired in parallel pairs means that the LEDs all have to be fairly forward voltage matched, except in this case because I'm wiring them in reverse. If they'd all just been in that one series string of 30 LEDs, you could have just put any colour in anywhere. You could have just made a real tutti frutti type LED lamp, just the hell of it. So that's the first outer ring of the LEDs done, and I'm going to start soldering around the outside now. So I'm going to place them down to hold them in place. I've got a soldering jig that holds circuit boards in place while you're soldering, but it's not that great with round circuit boards. And as it is, it's not that critical, because although these LEDs are all just moving about randomly as I move it, I'm going to just initially solder the positive and then I'll just line them up. I do notice the back of the circuit board, it doesn't have tinned copper pads, it's just bare copper pads, but they've obviously coated it with flux to make it easier to solder, which the solder is actually flowing on quite nicely. So I'm initially just soldering on the positive terminals of these LEDs. Now the soldering technique, if you're not used to soldering, the main thing to remember is you want a nice clean soldering iron tip. It has to be nice, clean and shiny. When you give it a wipe, it's absolutely glossy silver, and it takes the solder well, and it flows over evenly. You want, I always recommend the lead-based solder with the flux core, the standard electronic solder. And you never put solder on and carry it over to the joint. You always apply the soldering iron onto both the lead and the pad, and then apply some solder to flow in on, once they're both up to temperature. And that's how you get the good joint. And the reason for that is because the flux then flows out and it helps clean up and prepare the surfaces in real time. It just happens so quickly. And it mates the solder to both surfaces. One of these things that, get a soldering iron and start soldering, that's the only way to learn how to solder. So now I've soldered all the positive connections, and the LEDs are all sitting at funny angles, that's okay. What I'm going to do now is I'm just going to press gently against the back of each LED and reflow that solder joint. That's why I just soldered one pin initially. This one's sitting well down, so it's going to bounce up quite a bit. And that way they're just going to sit nice and even. If I was doing a normal sort of square or rectangular circuit board, I'd have probably put it in a jig because it's easier, but this one is round, and also the components are quite close to the edge, which does make it just that little bit harder to fit into the jig, because the jig has to grip the circuit boards at the edge. And it sometimes fills the components and makes them hard to access. So that's looking good. That's them. I'll get their positive connections soldered now. I'm going to solder the negative connections. The reason I solder the positive connections first is because the negative connections of the LEDs, the cathodes, are usually attached to the little reflector cup that holds the LED, and when I'm going to be sort of initially soldering and then repositioning them by flowing the solder joint, I think I just prefer to do the positive lead for that because it keeps the minimum of heat, because now the LED's in position and it's been reflowed and it's been pressed into place properly. I'm soldering the cathodes now, which means that the lead with the LED actual chip on it and the reflector is going to get the minimum amount of heat. It's not going to get exposed to as much heat as it would if I was like reflowing it to reposition it. I don't know if you'll hear it, but it's stormy again outside. That's not really that much a surprise. I do live on an island. It gets stormy here. I'm on the Isle of Man, and it's in the middle of the Irish Sea, between Ireland and the UK, and it just seems, well, it just seems very stormy sort of island. It's always been stormy. Okay, let's give these snips a go. So these are the red ones. Oh, they're quite zealous, I have to say. They're pinging the leads right off. I'm going to have to put my fingers over them to actually try and stop the leads pinging off too far. Yeah, they're quite good. And the next one I'll try the blue ones, the clear knockoff of an American brand, which is annoying. Don't like it when they blatantly pass these off as being, you know, I wonder how many of these are being sold in America as American made when they're really not. That's quite annoying. That I'm kind of pro keeping, you know, market, you know, places like actually making stuff in Britain and America, supporting American business and British business. So I'm going to put the next layer of LEDs in. Oop, bit footery. These are the LEDs of the really short leads. A lot of the ones from China seem to come with the short leads now. I suppose it saves the manufacturing cost of the metal. You know, it'll all add up. But it's actually, I kind of prefer the longer leads. It kind of makes it semi-convenient to actually solder these on, but it's more useful to have the longer leads for all applications. Now this is an odd number of LEDs, so I shall... oh, that's a wee bit... Oh, that is not... Oh, I'm going to have to... what's the best bet here then? I'm going to have to nudge them round. Because I've ended up with a pair that are actually a common pair that I've not got an LED in yet, so I'm going to have to nudge that round. That's better. Oh no, it's not, because, oh damn. I didn't think this through very well, did I? Right, I'm just going to pause a moment. And I'm back with all the LEDs conveniently soldered in, and I'll explain what happened there. The ring of LEDs that I was putting in had an odd number of LEDs. It wasn't nice matched number of pairs, and it meant that one pair was shared with an inner pair. Now, the way they're wired, they're a series multiple of these parallel pairs, and there's each pair of LEDs has two little links going across in the back. I can't really show you the tracks because it's this horrible white solder resist that completely obscures all the tracks out of sight. It's a bit annoying when they do that. But what actually happened, I'd come round to here, and because it's an odd number, inevitably you're going to end up with two blues of the same colour right next to each other, because it is an odd number. You're going to get a pair of LEDs. And just because of the way I'd actually put them in, it happened that I was going to end up putting two into one parallel pair, and they would have both been the same way round, so they need to be inverse parallel for the way I'm doing it at the moment, if that makes sense. But anyway, continuing on, let's get the red LEDs now. So now the red LEDs, which have the long leads, which is nice, I'm going to be putting these in the complete opposite way round, I'm going to be putting them in all the remaining holes, but in reverse order. And you know, I might as well just actually do these one at a time. So yeah, I'm based in Isle of Man. The Isle of Man is quite an interesting island. It's noted for its unusual mix of transport. It has horse-drawn trams, electric trams, really vintage ones. It's got steam trains and then all the usual other type of transports. It's quite an interesting island. Also known as a tax sort of haven, so to speak, if you will. There are a lot of millionaires live in the island, but they grossly outnumber by a very large margin the number of just ordinary people, which doesn't work out that well because it means that everything in the island is geared to high prices, and unfortunately that makes it quite an expensive place to live for ordinary mortals like me. And the reason I ended up living in the Isle of Man, my grandparents used to live here, and we used to come over like from the age 0 for our holidays every year. And it's just when my parents retired, they moved back across here. And now, because my mother's needing looked after, parental care, me and my brother ended up moving across to look after her, just because it was safer looking after my mum over here in the Isle of Man than it was trying to bring her back to a place like Glasgow, to a big city, particularly when she was in the early stages of dementia, Alzheimer's, and was wandering about. So I live in a place called Ramsey, a town called Ramsey, and it's nice enough. It's quite scenic. It's a sort of old, almost in a sense, it's got a lot left from its Victorian roots of when it used to be a holiday destination in Victorian era. So I live right next to a sort of big Victorian boating lake, which is quite what they call a pleasure lake, really, which is quite nice. It's lovely. It's still got an active fishing fleet, which is interesting. You often see the boats coming in and going out. It's always sort of busy, and of course, being an island, it's got a major farming community as well. It's an interesting place. It's worth coming here. It's interesting. It also hosts one of the most dangerous road races in the world, the Isle of Man TT, the Manx TT, which is a motorbike race done on pretty much the standard roads we drive on. But because the island is very sort of hilly and lots of twists and bends in the roads, it makes it quite an exciting race. If you've never seen the TT before, the TT race, the Tourist Trophy, then it's worth actually taking a look on YouTube and actually looking for some footage of it. It's absolutely crazy. So that's those LEDs soldered in. I'm just going to solder. Because I put them in individually, I've pressed them into the correct location, and they're nice and level. So I'm just going to solder the cathodes now of those LEDs. And then I shall crop them with the other pair of snips, the blue handled ones, just to see how they fare. The American copy. I wonder if that company still exists, the one in Maine. I might look that up on the internet. I wonder if they know their products are being ripped off. Particularly in this day and age when, it's quite hard to, run a manufacturing company. You can't really compete when China is selling clones at £1.22 of something that, you wouldn't even get the materials, you wouldn't be able to ship it out for that in America. So let's give these a go. Yep, they feel good. Feel very light. They got a very light spring in them, which is quite nice. These ones have the standard coil spring. These actually have this little springy bit of metal that presses against the side. It makes it very sort of a very delicate sort of feel. Right, not too many LEDs to go now. I'm going to have to remember and make sure I put these in the right way round. If I put them in the wrong way round, it's just not going to work very well. But you know what? No matter what happens, you'll see the end result, even if I screw up. I might actually just, rather than sew them one at a time, I might just sit this down and do it like I was doing before. The Isle of Man is also notable for it's got this strange thing. It's really all folklore, fairies and witchcraft and stuff like that. It was used as a penal colony for witches when back in the days when they were burning witches, just because they seem to have a softer stance on witches here, so they just deport them over here to the Isle of Man, and that would spare them from being burnt to death, which is lovely. That's nice. Makes you wonder what made them decide that old people were witches and should be burnt to death in old days, back in the when religion was just so harsh. Was it people with dementia that, you know, they just targeted these old ladies because they were a bit weird? And yeah, who knows? Dark histories. But as I say, on the Isle of Man, you know, I believe there are various covens of witches still on the island. Modern witches, internet savvy witches probably. No doubt selling their magical wares on the internet. I have no doubt they'll probably be doing that. Quite what those magical wares would be, I haven't a clue. It also has, of course, I mentioned it in another video, the Bagain, the monster that chases you through the undergrowth. It's quite the island it's also full of like this sort of strange standing stone type sort of things. It's got a strong Viking heritage as well. It's just an interesting place. So far, given the difference between these two snips, these ones, the blue ones, feel a bit gentler on the fingers actually. They're quite a nice feel they have on them. I won't use that slightest I'll use that for something else, but I'm not going to use it right now because it's just a wee bit short for reaching through the other component leads. In fact, you know, I can get this up higher. Now, it's notable that you can buy the entire lamp pre-made for pretty much the same as buying it in kit form, but that's not the point. It's the fact that you're kind of making a lamp yourself is quite entertaining. It's quite enjoyable just to do it as an electronic project. And choose your choice of colours, or mixing the LEDs if you so desire. Or doing what I'm doing and doing something completely weird and turning it into a psychedelic lamp that will alternate very quickly between two colours. Hopefully that'll pick up in the... I'm sure, given that iPad's tendency to pick everything up that flickers, it will probably show the vivid agitation of the colours quite well. These ones have a kind of like a... These are gripped, they're sort of knurled, but these are sort of rounder and fuller, but still they feel very light. They're quite good actually. An essential tool for electronic assembly, the little snips. And you can get super posh ones. You can get posh ones that cost about £30 a pair. But fundamentally, I've always used the generic sort of cheapy ones, just because they work very well. I'm guessing these are possibly from the same factory, by the look of it. These ones probably came from Rapid Electronics, not 100% sure. Right, I've only got a few more LEDs to put in. These ones are still going in the reverse polarity. In fact, you know what, there's only a few left to solder, so I'll just solder them individually. And then we'll stick the components in the back, the other components that are needed. I won't need the circuit board, I'm just going to mount the components directly on the back of this. I'll solder both those leads, in fact. Since it's getting a wee bit cramped in here now, and I'll switch back to these red ones. That's us almost there. This lamp is going to be very annoying when it's lit, because it is going to have that psychedelic shuddering effect of the colours. More useful as a novelty than actually trying to use it as a lamp, because that would get very annoying very quickly. I can guess what the effect's going to be. It's going to look that if you look directly at the light that's coming out of it, it will look that sort of red and blue mix. It'll look sort of purpley. But out the peripheral vision, you'll probably see it shimmer quite significantly, given that there's absolutely no smoothing, because it can't really have the smoothing, because the polarity is changing across the LEDs all the time. And let's get the last LED in. Another note about soldering: the most opportunity of burning yourself with the soldering iron is while you're just distracted and you're like poking around with something, and you will inevitably touch the soldering iron against your skin, and you'll hear a distinctive hiss noise, and it will hurt. And how long it stays against your finger depends how much it will hurt later, because a soldering iron burn is quite unpleasant. It's unfortunately just a fact of life. You will do it at some point, and I occasionally do still make contact. I've actually just bridged those two solder pads out. That's a bit amateur of me. I shall clear that. There we go. Right, so that's the LED panel made up now. Let's get the power supply. So I'm going to be using the capacitor out of that, which is 470 nano. And I'm going to be putting the 1 megohm resistor directly across that. So I'm basically just going to put it across the bottom of it and twist the leads round. This is the discharge resistor, just to stop you getting the nip off it. Technically speaking, this resistor is only rated for about 250 volts DC, so it's effectively getting its rating slightly exceeded on the AC 240 volt supply, because that will peak at about 330 volts, but I've not had any problems with them yet, which is a bit still not ideal. You'd be better using a resistor rated for the higher voltage, but it seems quite common, and as I say, I've never had a problem yet. If it did cause a problem, if it did short out, it would, that's the most likely scenario, I'm guessing. It would arc across, it would gradually short out until maybe it did flash across and then take out all the LEDs. That wouldn't be nice. Now, here's the two 1K resistors that I'm going to be putting in parallel. And when you put the resistors in parallel, if you get two 1K then in parallel, then that halves the value effectively. And if you had 3, it would divide it by 3. So I'm going to space them apart, I'm going to grip them and then twist the leads. And the reason I'm spacing them apart is so that when they're in use, if they were just pressed against each other, it would limit the heat dissipation from between them. They'd get a wee bit hotter there. So I just like to space them apart. So I'm just going to twist the leads together like that and put a wee bit of solder in that. And because I'm running this circuit board on AC as opposed to DC, it doesn't really matter which terminal. I've got the two wee solder terminals here, so I'm probably going to put the resistors on the middle terminal, like that, and the capacitor on the outer terminal. So I'll just crop this lead short, tin this, flick the solder off there, and that's another thing, another technique of soldering. I normally would recommend one of these. You get the wet sponge version of the solder tip cleaners, but I quite like this. It's very clearly an ashtray, a heavy ashtray that's been repurposed with this sort of brass scourer type thing, and it does the job very well. It really cleans the tip well without taking the heat away from it too much, which is good. The other technique you can use for cleaning the iron is if you've got a lot of solder on it, is flicking it. But there's a skill to flicking it, which you'll learn if you do it, to avoid flicking it back onto yourself with the solder. And the other technique is to lick a finger and just wipe the end and just get it off quickly, just to get the ends. Yeah, all the bad soldering techniques with Big Clive. But as I say, MD who solders knows these techniques. It's just something you just pick up over time. So the only way to learn to solder is just to do it, and then you'll get all these little techniques, as I say. So that's the power supply now attached to the back, just the resistors for one leg and the capacitor for the other, and that's it. So I'm going to cut those leads short, tin them, ready for the leads being put on, the connections of in the actual lamp housing itself. And this is where it might go horribly wrong. You're allowed to actually hope it goes wrong, because it does make things quite amusing when things go amiss, particularly if they go amiss with a loud bang and a shower of sparks. And that is a hazard with mains voltage projects. So I'm just tinning these leads. They're pre-tinned, but I prefer to put a wee thicker bit of lead-based solder on them. I know lots of guys who work in the electronics industry who have now retired, and they used lead solder all their lives, doing maintenance and soldering stuff, and none of them, to the best of my knowledge, has any adverse effects of that. There's this, people seem to get a bit hysterical about lead-based solder. It's not as bad as they make out. Right. So that's the lamp made, and this should theoretically just sit in here now, and this cover should just clip in, if it fits over the LEDs, which, is that fitting over the LEDs? That would be annoying if it didn't fit over the LEDs. Get out. It's a close fit, but yeah, it's alright. I should have been clipping this in before I've even... Oh, I tell you, it doesn't really clip in very easily. Is there a way this board is supposed to go? I don't think there is. I think it's just quite stiff. Is there a wee notch in this? I don't think there is. I don't think there's any specific position it goes in. I think I'm going to have to use brute force. That's just not clipping in at all. Maybe this is why they're giving them weird kits on eBay. Oh, that is not going in. That is very, very annoying. I don't think it's fouling because of the circuit board. I think it's just a very slightly over-tolerance fit. This is where the whole thing snaps when I use too much pressure. And at the moment when I try and work it round, it's just clipping out the other side. There it goes, that's it on. Rightio. It's time to test it. Will it go bang? Will it have the desired psychedelic effect? It's looking quite nice so far. I might not be thinking it's looking so nice when I plug it in. Only one way to find out. Where is my lamp holder? Oh yeah, that is... It's not as slow as it looks on the iPad at the moment. I'm just going to turn this light off, and I'm going to adjust the lighting a little bit. Is this going to make it a wee bit brighter? Yeah, okay. Now, that to me just looking directly at it, it's actually projecting a slight pattern, which is quite nice. It's quite a nice pattern, just sort of mottled. But now, when I move my finger like this, you can see it breaking up into that sort of strange red and blue alternation. Looking directly at it, it just looks as if it's lit with a very tiny shimmer. But if I look to the side, it shows that you get that peripheral vision thing. And it's creating that really vivid, it looks exactly to me as you're seeing it on the video at the moment, of that alternate red and blue sort of patterning. Very, very sort of 3D and psychedelic. That would be interesting with red and green, wouldn't it? It would give it that sort of 3D effect. But yeah, that's quite interesting. Let's get the power back on. I'll have to adjust this image down a wee bit. Come on, adjust, there it goes. And let's get the power meter in and see what that's drawing. So it says it's 2.2 watts at 34 milliamps. Now keep in mind that the 34 milliamps is actually being divided. Each LED is it's seeing the full 34 milliamps, but it's only seeing it for half the time. So it averages out at round about the sort of 17, 18 milliamps. What is that? 15? That's 17 milliamps roughly they're seeing. So that's well within their sort of range. But yeah, that is That's psychedelic is the best way to describe it. That's a very, very weird lamp. It looks quite nice when you're looking direct at it, because all you can see is the pattern of red and blue LEDs. But the effect of what it's actually projecting is really weird. So that was quite good. And we have ascertained now that the generic cheap snips, I mean, keep in mind that the Chinese must use, they must just eat these snips in their Chinese factories. You know, they must get through so many of them. So you're going to get pretty, I think it would be hard to get sort of bad snips off eBay. But these seem pretty good. For feel, I'd say the ones that are nicest, just for the feel, are these blue ones, which is odd because they're also the cheapest. They've got that little leaf thing now. I do know, I used to have a pair that you could actually click the leaf up and it took the sort of spring loading off. I don't know if you can do that with these. Where's the, have I got a, is it designed for that? It's probably not. No, I don't think it is. But anyway. Yeah, they're pretty good. Just annoying that they're such a blatant rip-off of... I mean, when I bought them I didn't realise they were going to come in this packaging, but it's quite annoying that they're actually, you know, put out in quite possibly a company's actual packaging. A complete clone, yeah, bit naughty. But yes, other than that, they're quite nice, and so's my lamp.